Hey there, this is Zach, and I wanted to share with you my July summer project called Randora. So, what it is a procedurally generated world with civilizations and a ChatGPT generated history of each nation. So, I wanted to walk you through how I do this and my major takeaways from it. And I'm going to keep it pretty surface level and conceptual. Feel free to dive into the code yourself or to reach out to me for further explanation on it. So, the first thing you do, or that the program does, is it generates Voronoi seeds. It generates these regions on the map. And what I do is for each region, I treat it as a tectonic plate, each with its own unit vector that acts as its drift direction, saying, "Hey, where is this plate going over time?" And then with all these plates, I see which ones are adjacent, and I do comparison on their vectors to see if they are going towards each other, which would be the white lines, if they're going away from each other, which is the black lines, or if they're transformed, going parallel to one another, which is the gray lines. So I store this information. Then, using Perlin noise, I generate a random blanket of altitude values. And with that, and with the fault lines, I then overlap the two and say, hey, I have this Perlin noise, but if it's near a converging line, it's more likely we're going to push that altitude up. And if we're near a diverging one, we're going to push it down. So that's how you get a more realistic looking world gen, where you get mountain ranges like this or bodies of water like this, is you use Perlin noise as a base to create shores and water lines like this, but then you implement or you add on top of that fault lines in order to show mountain ranges in a more natural way. So with having generated tectonic plates and a general terrain, then temperature is included. So with temperature, initially I was generating it per tile, but then the issue was that in all depictions of it, it seemed very generated because temperature comes from the equator. So the fall off math, like the expression of the falling off of temperature, was very obvious. So I instead opted for saying, well, this is part of a zoomed in part of the world. So we could say that the entire map is going to be either hot, mild, or cold. And then just applied a theme of colors to the map for that instead. And then had it affect resource generation directly, saying if you're in a hot area, you're more likely to have oil, or if you're in a cold area, you would have less grain, something like that. That's just an example. So once you have the map, you then do resource generation. So you have resources that are on the surface and then subsurface resources. And the reason for this is that once you get civilizations on there, I felt that having just one resource per tile was too limiting and led to major resource imbalances. And it'd be easier to display them this way as well. So you could see the maps if you overlaid them, where your surface resources are, which are grain and forests, versus your subsurface, which also includes mountains. Which is why in this region here you're getting a way larger cluster of stone. And the brown is oil and the white is salt. And salt and oil are really prevalent in the ocean areas. And the way that we generate random resources is we say, hey, what is the temperature of the area in general? And what is its altitude? And what plate is it most near? So with those things in mind, it then chooses it with assigned probabilities. It decides what resources there, if any. And if you're in a convergent area, you're way more likely to have stone, versus divergent, you're more likely to have oil and salt, etc. So once we have a terrain that is impacted by fault lines that has resources generated, we then find ideal civilization start points, and then the civilization begins to have simulate its own history. So the way that it does this is there is the civilization object or class and the city class. And the civilization tracks its like location in territory, its resources, and the cities it owns, while the cities then manage what resources are we gaining from the land beneath us, and manages the upkeep of having buildings, of having people, etc. Um, and with that, every year or round, it's just an incrementing number. This generation took 1,000 years, so 1,000 turns. On each turn, it determines whether it's going to build a new city or upgrade an existing city or do nothing. Um, and there are requirements for each of those that change over time. And it just randomly chooses which action it does. It holds a Python list of possible options and then just chooses randomly from that list. And the buildings for the cities have prerequisites. So you cannot build a marketplace without having a granary, and you can't build a blacksmith without a workshop to get the materials for that. And then once we've generated a civilization's history, that history is then prompted with an API key to produce a brief history, and it does that for each nation that's on the map. And if you want to try this, you'll have to use your own API key because it does cost quite a bit of money, just because my prompting is not very optimized, so I think it's very high in token usage currently. But in terms of takeaways on this project, it was a great introduction to Python as a language. This is my first project using Python. I come from a C++ background in college. So it was great understanding Python and getting to the luxury of using easily imported libraries and using stuff like tuples, lists, using the libraries NumPy and the plot library, and using random and all of that. It was great resources for all of that. It was a great refresher on object-oriented programming, like we saw with the city versus civilization. It was a great introduction to using the API key. I used one previously for a hackathon win, but this was I got to spend more time on it, and I was more involved with this API key than the previous project. And probably one of the bigger takeaways was that it was very interesting in terms of like math. There was a lot of math with the Perlin noise, with determining how much impact fault lines are going to have on it. Actually showing these lines on a map took some math. And then figuring out how to balance resource generation, like upkeep versus gain. And it was all done through the lens of my hobbies, which is world building and creative writing, and also games like Sid Meier's Civilization or even Minecraft with how the world generation's done. It was a great July project. I think I want to return to it in the future with a few more upgrades. I want to add a trading feature to Civilizations as well as war. But it was a great project. It kept me busy for July. Please reach out to me if you have any questions on this, or if you want to talk about it, or if you make any changes to the program and you find something cool out of it. Please reach out to me on my GitHub at arnoshake, ARNOSHAKE, or my LinkedIn, which is both are going to be linked in the description below. So thank you.